Good day, students. You are welcome to this STA 131 class. Today, we continue with measure of dispersion or measure of spread. But this time around, we want to consider group data. In our previous class, we look at ungroup data. Today, we want to look at group data. And under the group data, we are going to look at the variance, the standard deviation, as well as the coefficients of variation. So, I'm starting with the variance, the population variance. This is the expression. The expression is just a sigma square. That is sum of Fi into Si minus S bar square divided by N. That N, we can also replace it with summation of F, because our N is summation of F. That is the total frequency. So this one also, we can simplify it further into sigma square, which is sum of Fi square minus Ns bar square, everything divided by N, which is, we can also simplify further to sum of Fi square minus sum of Fx square divided by N, everything divided by N. So that is for population variance. For the sample variance, we have it to be S square. The only difference is just the denominator. So that is sum of Fi into Si minus S bar, everything square, divided by N minus 1. This one also can be simplified further into S square, which is sum of Fsi square minus Ns bar square, divided by N minus 1, which is can also simplify again as sum of Fisi square in minus sum of Fs square divided by N, everything divided by N minus 1. So for better appreciation, let's look at some examples. Example, you can look at this table. So we have the, as you all know, we are under group data. So this is the data. Then the frequency, we are given the frequency. At times, you may not be given the class mark. So you will be the one to obtain the class mark, which we also refer to as the class midpoint or the class rep. So it's you that will calculate it. So that is just 0 plus 4 divided by 2, 5 plus 9 divided by 2. Just take the limit, the lower and the upper limit, add them together, divided by 2. Whatever you get, that will stand as your class mark. And that's what we refer to as our X. Our F is the frequency. So we need Fs so as to obtain the mean. So that is what we did here. Then we also need and we obtain our mean to be 13.23. So to now obtain this F into S minus the mean, everything square. So this is what you are going to get. So we have done that on the table. And then the total Fs is 807, while the total sum of F into Si minus 13.23 square is 2082.79. Let's look at that on the expression. So you can see that the S bar, sum of Fs all over the sum of F. I've told us the sum of F is the same as our N, the N, the total frequency, that is N. So we have the mean to be 807 divided by 61, and that will give us 13.23. So for the population variance now, population variance, which also we refer to as sigma square, that is sum of Fi Si minus S bar square divided by N. So as you have demonstrated on the table, the sum for that particular F with deviation from the mean, 2082.79, you divide everything by 61, and that will give us 34.1441. We refer to that as the population variance. Population variance. Now, we can as well make use of the other form, that is simplified form. That is for the sigma square, we have the sum of Fsi square minus Ns bar square, everything divided by N. So by the time you do that, you have 12759 minus 61 into 13.23 square, everything divided by 61. And that will give us 2082 divided by 61. And that will give us 34.14. 34.14. Now let's look at the sample variance. For the sample variance, we have sum of f of Si minus S bar everything square divided by n minus 1. So the only difference is just the denominator. You deduct 1 from our sum of f or from our n. And that will now give us 2082.79 divided by 61 minus 1, and that will give us 60. So, and the result will now be 34.7132. That is the sample variance. And if you use the other simplified form, you are still going to have the same thing. That is 12759 minus 61 into 13.23 square. Everything divided by 61 minus 1. And that will give us 2082 divided by 60. And that will give us 34.7. So let's take another example for better appreciation. So given the following table on female student weight in AEF 204 was first class after COVID-19. They are first class after COVID-19. You know, they stay at home. Some of them, they became fatter. So that is why we are carrying out the research. So 3 of them fall within 30 and 34 kg. 35 to 39, 7 of them. 40 to 44, 13 of them. Between 45 and 49, 24 of them. 50 to 54, 17 of them. 55 to 59, 10 of them. So the total number of students under that experiment was 74. So the midpoint, as I've said, the midpoint is just a 30 plus 34 divided by 2. That will give us 32. 35 plus 39 divided by 2. That will give us 37. 40 plus 34 plus 44 divided by 2. That will give us 42, and so on. Then we also need the deviation. The f multiplied by the deviation from the mean. Our mean calculated to be the total. You take the total frequency, that is the fs. The fs divided by the n. So by the time we do that, we are going to have 47.0676. So by the time you do that, our f multiplied by each of these midpoint minus the mean and square, you are going to have 681, 709.5, 333.85, 0.11, 413.59, and so on. And the total frequency was 74. Then the total f into s minus s bar square will give us 3128.68. Now let's look at that expression. So as I've said, the mean, that's the sum of fs all over the sum of f. That is 3482 divided by 74. That was 47.0676. Now for the population variance, we have the sigma square, which is sum of f into si minus s bar, everything square, divided by n. That from the table, you just take the value from the table there. 3124.68 divide everything by 74, and that will give us 42.2. So which can as well be simplified further as sum of f of si square. That will give us 167061 minus ns bar. Our n is 74, s bar 47.0676. You square it and divide everything by 74, which is n. Because we are talking of population variance, we have to divide it by the total n, which is 74. And that will now give us 3124.44 divided by 74, and that will give us 42.2. Now let's look at the sample variance for that particular table. So s square, s for solar square, that's the sum of f into si minus s bar square, everything divided by n minus 1. That will make a difference. For the sample, it must be n minus 1. So the variance now is now going to be 312468 divided by 74 minus 1, which is 73, and that will give us 42.8. Then for the next one, to simplify it using the formula, we are going to have 167061 minus 74 into 47069 square. That is 47.0676 square. That is the mean. You square it. Everything divided by 74 minus 1, which is 73. So you are going to have 312444 divided by 73, and that will give us 42.8, which is the same thing. So we have come to the end of this the variance. The next is the standard deviation. As I've said, standard deviation under this particular one also is just the square root of the variance. For the group data, is just the square root of the variance. the population standard deviation for the first, that's the sigma square for the population. That is the square root of sum of f si minus s bar square divided by n. While that of sample standard deviation will just be the square root of sum of f si minus s bar divided by n minus 1. You take the square root of everything. So now this same one, we can have it in a short form as we did under variance. So for the population standard deviation, we have the sum of fsi square minus sum of fs square divided by n, everything divided by n. Then for that of sample, is sum of f of si square minus ns bar square divided by n minus 1, or sum of f of si square minus sum of fs square divided by n, everything divided by n minus 1. For better appreciation, let's take example. Now, given the following table on student score in AEF 204 continuous assessment, as I've said, continuous assessment in this university is 30. The score must be 30. So whatever you score over 30. So taking the distribution of these students, you can see that 4 of them score between 0 and 4. 11 of them score between 5 and 9, and so on. Only 2 score between 25 and 29. So we need the midpoint. That is 0 plus 4 divided by 2, 5 plus 9 divided by 2, and so on. That is how to obtain the midpoint. That is the class rate or the class mark. Then the FS, for us to obtain the mean. So that is that. And the total FS is S07. The total frequency, 61. Then the F into S minus mean all square. And that is F into S minus 13.23 square. So the total for that one is 2082.79. So let's look at that. For the mean, we have it to be 807 divided by 61. That is 13.23. So the population standard deviation is this. So, and that is it. That is square root of 2082.79. Everything divided by 61. And that will give us the square root of 34.14. And that is 5.8429. The variance here is 34.14, while the standard deviation is 5.8429. That is for the population. So if you want to simplify, you can also use the equation form. You are still going to arrive at the same thing as you have expressed it on that one. That is for the standard deviation. We have the square root of 12,12759 minus 61 into 13.23 square divided by 61. And that will give us 2082 divided by 61, square root of everything. And that will now be the square root of 34.14. That 34.14 is the variance. Then the square root of it, 5.828429. So now for the sample standard deviation of the same table, so we have it. Since already we have the upper one to be 208279. The only difference is just the denominator. You deduct 1 from it. So by the time you deduct 1, that will now become 60. So we are now going to have the variance to be 34.7. By the time you take the standard deviation, to take the standard deviation, we take the square root. The square root of that variance will give us 5.8907. So if you use the simplified form, also you have it to be 12759 minus 61 into 13.23 all square divided by 61 minus 1. And that is the square root of 2082 divided by 60. And that's the square root of 34.7. That 34.7 is the variance. Then the square root of it is the standard deviation, which is 5.8907. So let's take one more example for better appreciation. So this one is student score in examination. This time we are talking of examination in AEF 204. So we have to obtain the standard deviation. We want to obtain the standard deviation. You can see the frequency. 43 students score between 10 and 19 over 100. 20 score 110, score between 20 and 29. 237 score between 30 and 39. So 141 score between 40 and 49, and so on. So the midpoint, we have it 14.5, 24.5, and so on. So the F into S minus the mean is 37.8281, everything square. So the total for that particular one is 106611.1. So now let's look at the expression in the formula form. So the mean, as you all know, the first thing to do is to obtain the mean. The mean will now be 24210. That is 64.0. So the average score for that particular exam was 37.82, which is too bad. That's a mass failure. 37.82. It's not even up to 40. So God will help us. So the population standard deviation, that is the standard deviation, that is sigma square. So is the square root of the variance. So by the time that is the formula, then already we have obtained the upper one on the table. Just slot it in. That is 106611.1 divided by 640. That will now give us the square root of 166.59. That 166.59, that is variance. Then the square root of it, that will now give us 12.9066. Or in a simplified form, you can as well have it. That is sum of FSI square minus NS bar square. And that is also giving us 1022430 minus 64039.8281 square. Everything divided by 640. And that will give us 12.9066, which is in agreement with the one we obtained directly. Also, we let's look at the sample version of it, the sample standard deviation for the same table. So I also have told us we only need to deduct 1 from our n, which is our sum of f. So by the time you do that, you are now going to have 639 as denominator. So by the time you do that, you use that one to divide 106611.1. You are now going to have 166.84, which is the variance. Now, the square root of that variance will now give us the sample standard deviation, which is 12.9167. And if you use the simplified form, that is sum of f of si square minus ns bar square. So that will now give us 1022430 minus 640 into 37.8281 all square divided by 639. And that will give us 106612.3 divided by 639. And that will now give us 166.84. That 166.84, that is the variance. The square root of it will give us the sample standard deviation, which is 12.9167. So that is the end of standard deviation for group data. So we now move to the last one in this particular unit, which is the coefficients of variation for group data. As I've said before, coefficient of variation is just for comparison. We use it for comparison. If you want to compare two different populations, you have to make use of coefficients of variation. The one with the least coefficients of variation standout is the best. The CV, as usual, is SD divided by the standard deviation, SD divided by the mean multiplied by 100. SD, that is the standard deviation. So let us illustrate this also. So from this table, we have this the classes, we have the frequency, we have the class mean, we have the FS, and we have the F into S minus 13.23 square. So already we have the standard. What we need here is the mean. The mean 13.23, and we also need the standard deviation for the population. Now the standard deviation for the population here was 5.8429. So from here now we can come up with then that of sample also. We can see the standard deviation for the sample. The standard deviation for the sample is also 5.8907. So the next thing now, we want to look at the coefficients of variation for both the population and that of the sample. We want to look at the coefficients for both population and that of sample. So this is the coefficient of variation now. SD divided by S bar multiplied by 100. For the population, the standard deviation for the population is 5.8429. So divided by the mean, which is 13.23, multiplied by 100, that will give us 44.16%. Now, the standard deviation for that of sample now was 5.8907, divided by the mean, which is 13.23, multiplied by 100. That will give us 44.53%. So for better appreciation, let's take one more example. Given the following table on female student weight in AEF 204, first class after COVID. We've considered this table before. So what we need is just the result. You can see the mean. We need the mean. That is 47.067. That is the average weight of student returning after returning from COVID. That is the average weight of female students in that particular class. So for the population, we have the population standard deviation to be 6.4962 and the sample standard deviation to be 6.5422. Now we want to look at the coefficient of variation for this particular table. The coefficient of variation, now we have the SD all over the mean multiplied by 100. Now for the population, we have 6.4962 divided by 47.0676, everything multiplied by 100. For the population, we have 13.80%. Then for the sample, we have 6.5422 and then divided by 47.0676, everything multiplied by 100. And that will now give us 13.90%. Students, we have come to the end of this particular class. In our next class, we are going to look at measure of position. I wish you best of luck. Thank you.